Can humans survive in the vastness of outer space without the protection of a spacesuit? A question that teases the edges of our curiosity and pushes the boundaries of our understanding. It's a riddle that challenges our perception of life as we know it and demands us to rethink the limits of human endurance. It's not just about survival, but about how far we can go in our quest to conquer the final frontier. So let's explore the answers in this video. The vacuum of space is not a hospitable environment for humans. This statement may seem stark, but it's a reality that we must confront when we consider the cosmos beyond our own atmosphere. But what exactly do we mean when we say space is a vacuum? In essence, a vacuum is a space devoid of matter. In the context of outer space, this means an absence of air or atmosphere, no oxygen to breathe, no pressure to keep our bodies intact. It's a stark contrast to the life-supporting environment we're accustomed to on Earth. Now, let's delve a little deeper and consider the implications of this vacuum for the human body. First and foremost, the lack of oxygen. Humans, like many life forms on Earth, require oxygen to survive. In the vacuum of space, with no oxygen to breathe, unconsciousness would occur within 15 seconds. But that's just the beginning. Next, let's consider temperature. Space is a place of extreme temperatures, both incredibly hot and extremely cold, depending on whether you're in sunlight or shadow. Without the protective layer of our atmosphere to moderate these temperatures, a human exposed to this environment would experience these extremes firsthand. But the vacuum of space doesn't just present challenges in terms of oxygen and temperature. There's also radiation to consider. The sun, along with other celestial bodies, emits a constant stream of radiation. On Earth, we're largely protected from this radiation by our atmosphere and magnetic field. However, in space, without these protective layers, humans would be exposed to high levels of radiation, which can cause severe health issues, including damage to the nervous system and DNA. So, as you can see, space is not just a simple vacuum. It's an environment of extreme conditions, from lack of oxygen to intense temperatures and radiation. These factors make it an incredibly hostile place for humans, especially without the protection of a spacesuit. Clearly, the vacuum of space presents serious challenges for human survival without a suit. And with that, we've only just scratched the surface of what it means to be a human in the vast, uncharted expanse of space. One of the immediate dangers in space is the effect of decompression on the human body. Now, let's dive into the science behind decompression sickness, a condition you might have heard of as the bends. This term was coined by deep-sea divers who, after spending time under high pressure deep in the ocean, would ascend too quickly to the surface and experience a host of medical problems due to rapid decompression. The same principles apply to the vacuum of space. Space is a vast, unending expanse of near-zero pressure. When the human body, acclimated to the Earth's atmospheric pressure, is abruptly exposed to this vacuum, it undergoes a violent decompression. So what happens during this decompression? The sudden reduction in pressure causes gas bubbles to form in the bloodstream. These bubbles are primarily nitrogen, a gas that is usually dissolved in our blood under Earth's pressure. However, when the pressure drops rapidly, the nitrogen comes out of solution and forms tiny bubbles. It's like opening a can of soda. The gas dissolved in the soda forms bubbles when the can is opened because the pressure inside the can is suddenly reduced. These nitrogen bubbles can wreak havoc in the human body. They can block blood vessels, causing tissue damage and potentially leading to heart attacks or strokes. They can also cause severe joint pain and rashes. In the lungs, these bubbles can cause a condition called barotrauma. This is where the tissues of the lungs rupture, causing severe pain and difficulty breathing. But it's not just the gas bubbles. The rapid decompression can also cause the water in the body to boil at body temperature. This is known as ebullition, and it can cause severe swelling and damage to tissues. And we're not done yet. The decompression can also cause the oxygen in the body to rapidly deplete, leading to hypoxia, a condition where the body or a region of the body is deprived of adequate oxygen supply. Decompression alone could be fatal to a human exposed to space without a suit. So if you're thinking about a spacewalk, make sure you're suited up. The extremes of temperature and the high levels of radiation in space are further obstacles to human survival. Now, let's dive into these two elements and understand why they pose such a significant threat. In space, temperatures are not like what we experience on Earth. When in direct sunlight, temperatures can soar to over 250 degrees Fahrenheit. Conversely, in the shadow of an object, temperatures can plummet to below -250 degrees Fahrenheit. Imagine, if you will, being subjected to such drastic temperature changes without any protection. Human bodies are not designed for such extremes. Our cells would be destroyed, leading to severe burns in the sunlit areas and frostbite in the shadowed ones. However, temperature isn't the only concern in outer space. There's also the matter of radiation. On Earth, our atmosphere and magnetic field protect us from the majority of space radiation. But in space, without the protective layer of the Earth's atmosphere, we're exposed to a constant stream of high-energy particles. This radiation can have devastating effects on the human body, damaging our cells and our DNA. Over time, this damage can lead to an increased risk of cancer and other severe health issues. So, how do astronauts survive these harsh conditions? The answer lies in their spacesuits. These are not just outfits, they're personalized spacecraft designed to shield the wearer from the harsh realities of space. They regulate temperature, keeping astronauts warm in the shadowed areas and cool in the sunlight. They also provide some protection from space radiation, although it's still a significant concern for long-term space travel. In short, without a spacesuit, a human in space would be exposed to extreme temperatures and high levels of radiation, both of which could cause immediate damage and long-term health problems. As you can see, the temperature and radiation in space make it a very hostile environment for humans without the right protection. So, given all these challenges, is it possible for a human to survive in space without a suit? You might be wondering. Well, let's delve into the few known instances where people have survived brief exposure to space-like conditions, and what this tells us about the limits of human endurance. In 1966, a test subject at a NASA facility was accidentally exposed to a near vacuum when his spacesuit failed. He lost consciousness within 15 seconds, but was repressurized after about half a minute and suffered no long-term ill effects. This was a close call, but it shows that brief exposure to space conditions isn't necessarily fatal. In a different scenario, back in 2001, the crew of the International Space Station lived through a minor depressurization event when a supply ship collided with the station. The crew had time to put on their emergency oxygen masks and survived, demonstrating that quick thinking and the right equipment can make a difference in a crisis. These instances suggest that the human body is surprisingly resilient. However, it's important to remember that these were controlled situations with immediate intervention, far from the harsh realities of being stranded in the vacuum of space. On the other hand, what about enhancing human survival in space? Well, researchers are exploring the field of human hibernation or torpor, which involves reducing a person's metabolic rate to increase their chances of surviving in harsh conditions. This is still very much in the realm of science fiction, but it's a fascinating concept that could revolutionize space travel. There's also ongoing research into developing more efficient and lightweight spacesuits, as well as potential medical interventions that could help the body withstand the effects of radiation and decompression. While we're still a long way from being able to survive in space without a suit, these stories and research efforts show that we're not giving up. After all, as we've seen throughout history, humans have a knack for overcoming seemingly insurmountable obstacles. While the odds are stacked against us, the human spirit of exploration and discovery continues to push the boundaries of what is possible. Let's revisit the key points we've discussed today. We've journeyed through the unforgiving vacuum of space, where the absence of air pressure leaves no room for human survival without the protection of a spacesuit. We've delved into the terrifying consequences of decompression, a phenomenon that would leave the human body in a state of rapid expansion and ultimately death. We've explored the extreme temperatures in space, both searing heat and freezing cold, that our bare skin is simply not equipped to handle. We've gazed at the invisible enemy that is cosmic radiation, an insidious force that can damage our cells and DNA without us even noticing. But amidst the harsh realities, we've also glimpsed at the slim possibilities of survival. We've learned that a human could potentially survive for a brief period, perhaps up to 2 minutes, if they exhaled before exposure to prevent lung rupture and were quickly repressurized. However, these possibilities do not change the fact that space is a hostile environment to humans. The necessity of spacesuits is undeniable. They are not just for show, but our lifeline, our personal habitat in the void of space. While we continue to dream about exploring the universe, it's clear that we'll need more than just our bare skin to survive the journey.